Hi, this is Merlin. I'm just gonna talk about Valorant today. Today, as you just know, I'm making actually bit tree algorithm, and I'm making like deletion part because I already implemented search and insertion. Um, I think it's really hard. So what do you mean it's really hard? So if I try to explain with those kind of graphs thing, let's say, um, let's say you have, like, wait, hold on. Let me just trying to make it like this. Yep, pretty nice. So you have those kind of bit tree. So example, this wait, hold on. Is this right? I think this is, but whatever. So yeah, like this is really perfect. Putting here and like this is pretty nice. So this is actually bit tree representation using text. The root is going to be 17, and the left is going to be 10, and right is going to be 20. The instruction is really simple. If it's overflow, you merge with the parents. It's really simple. But if your parent that already being merged is already full enough, you have to merge. You have to do same stuff, but you have to make the pointer on. You have to change pointer in the parent because you have like this. But insertion was kind of hard, but it was really I can do it, but the deletion is kind of hard because there's so many things to consider. Example, yeah, that's 30. If you're trying to delete, let's say our minimum degree, let's say let's say t is 2. So t is 2, which means that the max keys that node can handle is 2 times t minus 1. So that's gonna be 3. So, and also the minimum key that node can have is t minus 1. So that's gonna be equals to the 1. So we have to make sure that make sure to follow these rules. Let's say we're trying to delete let's say 6. If you're trying to delete 6, there's no gonna be issue of it, because if you're trying to delete 6, this node is already balanced. It follows the rules that our minimum keys is 1 and our max keys is 3. It really follows the rules of it, and there's no issue of it. Even you delete 7, there's no issue. But when it goes below this minimum key, if you're trying to delete 5, there's gonna be issue of it. Oh, what do you mean why? Let's say like this. Let's say you are trying to delete 18 and you're trying to delete 19. Since you reach that your current key is less than minimum key, you have to really borrow from the siblings. In this part, the sibling is here. So you borrow 21 on the parent, and let's put the 20 on the child. So example, if you're trying to delete 18, so this gonna be like this. Let's delete this unnecessary part here. This is kind of bothering. So let's delete 18, 19 because I already did it. So 21 we have to borrow to 21, right? Because that's from the siblings. So if you're trying to borrow 21, and we have to put the 20 on the bottom, on the left. So if you're trying to do this stuff, this tree, the bit tree, it does follows these rules. But what if, okay, so we're trying to do, like, if you're trying to rank, if we trying to delete the 20 again, we can just follow these steps. So if you're trying to delete 20, so 20 is gonna be gone, so 21 has to go bottom on the left. Okay, why is it disappearing? Never mind. Just delete this part. No. So the 20, if we trying to delete 20, we have to borrow from siblings, right? So that's gonna be 21. We borrow 22 on the siblings. So 21 go to the left and 22 go to the parent. So that's pretty good. But what if you delete this 21? Okay, we're gonna try to do the same stuff. You have to borrow the key from the siblings. But even though we borrow from the siblings, it's already unbalanced. So that's gonna be tricky part of the B tree. So what you have to do is, yes, you're trying to delete 21, so it's already gone. And next, you have to get the parent node, and you have to, your target node is this part. You have to merge this parent node into target node. So the B tree is gonna be like, there's no node here. So it's gonna be like this. But we encounter issue that this keys is already unbalanced. So what we have to do is we have to already traverse back, because our pointer was this part. We have to traverse back into 17. Okay, now 17. So what we did was in this part we just know that even though we borrow from the siblings, this subtree is gonna be unbalanced. So let's just adjust it on also in this part. If you look at 17 and 10 and this node with a no key, this will be unbalanced. So it's gonna be do same thing what it does. We make the 17. We make the 17 merge with this 10. Target node, let's say let's say 10. So there's gonna be empty. Empty. So that's pretty nice, but wait, hold on. 17 we have to tell it. Yeah, even though now this part. So this 17, 10, and 5, 6, 7 is already pretty nice, but since oh yeah, we have to merge this part or so. So we have to merge this. So we have to merge this, so the 10 is gonna already gone. So the key is gonna be like this. But if I trying to demonstrate this kind of subtree, this kind of tree data structure into some kind of box, here 17. Yeah, we have to put 10 here, and we have to put 17 here, and there's a 5, 6, 7. 5, 6, 7, and there's also 12. There's empty node. There's 22 and 30. Yeah, I think we have to merge this stuff. We have to merge this, because we have to merge this, yeah. Isn't it? Yeah, this is super tricky. If you're trying to merge, yeah, we have to merge this part. Yes, we have to merge this. But isn't it? Oh, this is kind of hard. I think this is really hard because you find out that which one you have to merge, like this part or this part. So, but whatever. So if you're trying to make it like this, so final goal is making like this. And tada, you already made a B3 here. Yes. So this is really how you make how you handle those kind of B3 deletions. But I think you already found out that which one has to be merged, and is this node or is able to be deleted or not. So I think that's kind of a real issue of it. And the theory is kind of easy because even though I stuck in here, I can just demonstrate with the diagram. But I think the most important part is that like making this theory into real world, making this theory with the code is really hard part. But I think I'm just gonna try to make it. I'm pretty sure I can make it. So I don't know what's gonna happen. So this is the happiness station. Next time, bye bye.